My research includes the development of integrated system. So I integrated three individual systems, which makes use of the waste energy of one system can be used as a source for other system. Uh, I plan to implement these systems in a real scale. So I developed a prototype which is based on Chief Minister's solar powered greenhouse scheme, which is which is for people below poverty line, below poverty line. I made a prototype based on the Chief Minister's solar power greenhouse scheme, powered greenhouse scheme, which is in the Ministry of Rural Development and Panchayat Raj. And then we integrated the building with we coupled the building with the integrated system that what we developed, and we analyzed what is the problem inside such systems. Uh, the photovoltaic system, the problem in the photovoltaic system in a sunny climate is its temperature level. So if the temperature increases, automatically the voltage drop will be there, and thermal stress increases. So automatically the power production reduces. So it implies we need an additional cooling system for a PV panel. In India, the average solar energy radiation is more than 900 watts per meter square in the summer. So in that condition, the temperature of PV panel surface is very high, more than 60 to 70 degrees Celsius. So we need to remove the heat from the panels. So automatically the power will increase. But how? So again, solar chimney is another device which uses air which moves the air passively for air ventilation. Which works on the principle of density difference. The air gets heated, and once it gets heated, its density reduces, and automatically it is lifted to certain level by an additional chimney. Chimney works in a stack effect. So the air, less dense air, is pushed out through a chimney automatically, naturally. So automatically the air can be transferred from one place to less height to higher height using the help of a heat source and chimney. So I integrated the solar PV with chimney, so the heat energy from the PV is utilized by the air. So the fresh air can able to take away the heat from the PV panels, so which is mutually beneficial. So we can solve the problem. We can increase the power as well as we can improve the air ventilation rate. So again, next is the water. In water, clean water production, I used solar still, which operates based on the evaporation and condensation technique. Solar radiation is used to evaporate water, and once the water evaporated, it gets condensed. So as condensation concerned, it occur a less temperature surface where the water gets condensed. So in condensation, there can be a chance that that's a release of enormous amount of energy in the latent heat of in the form of latent heat, and which can be utilized in solar steel concerns. There are main problems in solar steel. So there are many ways we can improve the evaporation rate of solar steel, and there are many ways which can improve the condensation rate of solar steel. So in my integrated system, I use the condensation rate of solar steel to be carried away by the air. So I integrated a solar still with the solar chimney, and the fresh air from the solar still which takes away the heat from the condensation, so which reduces the condensation surface, and automatically the water production is increased. There are three systems which is integrated to there are two individual systems which is integrated to a common solar chimney. So there we can get multiple outputs, three outputs like air ventilation, clean water, and power. Uh, which is better than an individual system. So I then continued with the energy analysis, environmental analysis, and economic analysis, which also gives you the impact of integrated system over an individual system. The energy payback of integrated system is very high, very less than individual systems. And then the environment analysis concern, uh, we had done life cycle analysis, and from the life cycle analysis, we combined it with the RO unit as well as the coal electricity and an exhaust fan system. So there we get to know about the impacts of carbon dioxide emissions daily, yearly, and how long our integrated system need to like in the extraction, production, transportation stages, and end of life stage of developed system. The carbon dioxide emissions during those stages, it's a major concern while development of while choosing the materials. So we had done an environmental analysis and find out what is the impact to the environment and how it is better than the commercially available systems like RO unit, exhaust fan, coal electricity. And then economically we had checked the feasibility of the integrated systems. And it shows that we need a more focus in the design and development for such integrated system, which if we need to move that into a commercial one or a application, it's a working one, we need a more focus on the design of the system, and which is a major task I'm working in